Hello class, it's Mr. Kaplan again here, and I'm here to do the last lesson for chapter 2 dealing with plotting points on a Cartesian plane, but specifically we're going to be looking at a specific type of graph called distance time graphs. Now you'll be spending a lot of time on these type of graphs if you decide to take, for example, grade 11 physics, but it's a good introduction for you to understand how we can use plotting points on a Cartesian plane in a real life example. So let's take a look at this lesson over here. And again, when we're taking a look at this over here, it's going to be a little bit hard to wrap your head around it at first, but keep in mind that as long as you understand the basics of these graphs, it's pretty understand to see what's happening when it comes to lines and curves when it comes to distance and time. Now, what you need to know about distance and time is that when you're comparing it when you're looking at whether something is independent or dependent variable, okay, notice that in this case over here, the time, which is on the horizontal axis, okay, that would be the independent variable. Now, typically, time is the independent variable because time is what's in control. And if you take a look at time, time always goes forwards from left to right. Okay, in this case here, the distance would be the dependent variable because that's the variable that's being measured or the one that's being controlled by the time in most cases. So when we're looking at a distance time graph, we're looking at the position that an object travels over a period of time. Now, just to describe distance time graphs for this particular example, okay, notice that we have three sets of lines. We have lines going up, we have a line going down, and we have a line that's going straight across. Now, what you need to know about on a distance time graph, and anytime you see a line on a distance time graph, is the fact that lines on a distance time graph always represents what's called constant speed. Okay, and I'll discuss that in just a moment. Now, what you need to know about the direction, okay, as I said before, it goes in three general directions when it comes to distance time. It either goes up to the right, down to the right, or across. Now, anytime you're looking at a distance time graph, and any graph, whether it's a line or a curve, okay, that's telling us that you're moving away from your starting point. So what this means here is that this object or this person, whatever the case may be, is starting at some point and then is moving away from it. So that's what this line represents. Okay, so that's why it says here, a rising line shows that the distance increases as time increases. Now, if you look at the one right beside it, it's a line that's going down. Okay, so as a falling line shows a decrease in time. So what this means here, and a good example of this is that a person, for example, starts at their house, for example, okay, and starts walking away from it. Okay, this downwards represents the fact that the person is now heading back towards their house. Okay, that's a good way to understand what a down line represents. Now, this line over here, okay, where it says the distance is constant, and this is the important part that I want you to see for this one. Okay, notice the key thing that you need to know about any line that's going straight across. Okay, this what represents no motion. Now, no motion is exactly that. The object or person is not moving. So another way to see it is that the object or the person is stopping. Now, when you're looking at this line over here, notice that this line going across keeps on going. Okay, because that tells us that this object or person, okay, is staying still, but time is still going. So that's what this represents over here. Okay. All right. So when we're looking at distance time graph, and keep these in mind here is that anytime you see a straight line, okay, it always represents constant speed, okay, which means that the person's speed is never changing. Now, when you're looking at lines, okay, the steeper the line is, okay, the faster the object is moving. So if you're looking at a set of lines over here, always take a look at which one is steeper, and the steeper line represents faster motion of that particular object or person. Okay, and this is another key point over here. So make sure you put a star beside it, highlight it, do something with it. Okay, straight lines indicate that the speed is constant. This is very important. Now, again, just to remind you what this means here is that the person is moving and their speed is not slowing down and it's not speeding up. So that's what it means when the speed is constant. All right. So let's take a look at a few examples here so you have a better understanding of what it means to have lines when it comes to direction and speed. All right, so the first example that we have here, Okay, we have 1, 2, 3, 4 different sets of lines, and each set of lines tells us something different about the movement of that object. So it says for the graph pictured, identify the motion and direction of the object. Now, what this is asking you to do here is that for each set of lines, okay, describe whether it's is moving away from where it started, okay, and in comparison to the other lines, is it moving faster or slower? So for AB over here, okay, notice again, this is going to be a person that's moving away from where they started at a constant speed. Okay, so these are all constant speed, by the way, A to B, B to C, and D to E, because again, these are straight lines, which means they're moving, and they're moving at a steady pace. Okay, so that's going to be A to B. Now, if you take a look at B to C, the person's still moving away. However, since this here is steeper than A to B, okay, it's a faster movement away. So A to B, they're still traveling, but from B to C, okay, notice that their speed has gone up, but they're still traveling at a constant speed. Now C to D, anytime you see a horizontal line, this means the person or object has stopped moving. Okay, and notice I put there in brackets, no change in distance, which means they're just standing still. All right, last but not least, we have D to E over here, okay, which now means that this object or person is now returning towards the starting point. Okay, and I want you to see here is that when you're looking at the lines in this case here, A to B and B to C, which are going up, and D to E, which are going down. Okay, notice that all three of them have different different steepnesses. So that goes to the next question: is which line segment represents the fastest movement, and how do you know? So that means we're taking a look at lines A to B, B to C, and D to E. Keep in mind that we're not factoring in direction here. We're looking strictly at steepness. So if you just do a quick comparison of A to B, okay, and B to C, okay, you notice B to C is steeper than A to B, okay, so we can determine that. Now, to compare B to C and D to E, okay, notice that even though B to C is going up and D to E is going downwards, okay, by looking at D to E, this line here is steeper than B to C. Okay, so segment D to E is going to be the part of the graph that tells us that this object or person is moving at a faster constant speed there. Now, I'm just going to briefly talk about how we can actually calculate that, but we're not going to even look at that until the next chapter, is that you're going to learn something called slope, okay? And basically that's just a measure of steepness of a line over here. So if we were to assign a number, and I've just used this as a guide, okay, where if you look at the spot going up and down like so, okay, this has a rise of rise of 2 and a run of 1. Like I said, we're going to spend a lot more time on this in the next chapter, so I just want you to understand why this is steeper. Okay, and basically what happens over here is that when you're looking at the slope of this line over here, we have a slope of 2 over 1. So this tells us over here that this here would have a slope of that. If we did the same thing to part for B and C over here, and I'm just going to do it on the screen over here. So if we were to do the exact same type of calculation over here, like this, okay, so we would have a rise of 3, okay, and a run of 2. Okay, so 3 divided by 2 would give us 1.5 or 1.5, which is smaller than the 2 that we have over here. So that's just a numerical way of doing it. Like I said, we're going to spend a lot more time on that in the next chapter, but that's just a way to explain it using numbers. Okay. All right, so I'll take a look at more examples over here. And what we want to do for the next one is to look at 2 types of graphs and simply just to communicate the direction as well as the speed. All right, so for part A over here, take a look at line segment A to B and B to C. Now remember, anything with a straight line represents what's called constant speed. Now what this is going to be here is the fact that since we are starting from this point over here and it's going downwards, this person is going in a direction which I'm just going to label simply as towards. So what this means here is you can see it's fast movement towards the starting point. Okay, so we're going to assume this point 0 here, let's just say is home. Okay, and this person is like, I don't know, at school. So this person is basically making their way towards home. Okay, at a constant speed, which means again, they're not going to be changing their speed. They are constantly just going at the same pace. All right, and B to C is a horizontal line. That means that they're stopping or no motion. All right, here's where it gets a little complicated. So I want you to picture your mind over here, and I want you to think about riding a roller coaster. And I apologize to those people who have never been on one. Okay, so when you're riding a roller coaster, for example, as soon as you go up to the top of a peak of the top of a roller coaster, okay, you notice there's that dip there, that dip that makes your stomach kind of churn. Well, that's going to help you understand how this graph here works. So what we're going to do here, notice that what we have here is nothing is straight except for this last part. So think of a roller coaster again. So the first thing we want to do here is take a look at A to B. Now, when you're looking at A to B and you're thinking about the roller coaster, okay, this is the moment where you reach the very top, okay, and then you go down the roller coaster and then you put your hands up, okay, and you have that feeling in your stomach there. Now, the reason why you have that feeling is because that's a very, very sharp dip. Now, keep in mind that what we want to just look at here is the fact that anytime you see a curve, okay, that means that there's going to be a change in the speed. Now, the way this can be a little bit tricky at first, but again, this just make sure you can follow along here. If you look at A to B, now as I travel down A to B, or you're going down the roller coaster over here, this is when the speed increases. Okay, and the reason for that is because as I go down from A to B, the curve is getting much steeper. All right, so since this curve is getting much steeper, that means there's an increase in speed, which you can also know as acceleration. So what we have here is a description is fast movement towards the starting point, and you notice I've underlined and bolded the word increasing. Okay, so from point A to B, the speed is constantly changing there. All right. Now again, going back to the roller coaster example, so you finally have that little thrill in your stomach there, and then it starts to come down. Okay, and we're now looking at part B to C. Okay, and this one over here, you can look forward not only just for B to C, but what happens to C to D over here is that after you have that sharp dip there and it goes really fast, okay, a roller coaster then starts to slow down because it eventually stops. Okay, so that's a good way to understand that. Now, when you're looking at this little tiny part of the curve over here from B to C, okay, notice that this curve here is now becoming less steep. So since this curve here is becoming less steep, the speed there is decreasing. Okay, so that's going to be an example of decreasing speed. And again, anytime you see a change, you see a curve, that always represents a change in speed. Okay, and last but not least, as I said before, C to D, okay, that's going to be no movement. So again, that wraps up the final lesson of chapter 2. Okay, so you can now proceed to the review. Okay, please work through the review and check your answers to see if you're on the right track. And if you have any questions, be sure you address it on LMS. Take care.